Good afternoon to all.
Yes, sir.
Is it audible? Whether the screen is visible? Everyone?
Yes, sir.
Yes. Okay. So what are you studying? What we studied in the last class? That is impact. Okay. Impact. What are the different types of impact? Direct impact, oblique impact, central impact, and eccentric impact. Correct? Yes. Is it audible?
Yes, sir.
Okay. So whenever two bodies are coming and they are undergoing the impact, so they are coming with the initial velocity u. Correct? So when they come and they collide each other, So there is the initial velocity u. So during this collision, there are two processes are going to happen. One is they undergo maximum deformation, and afterwards they are going to go separation. Okay, they are moving with the initial velocity u, and they will undergo maximum deformation. That period is called as period of deformation. What is the period of deformation? When the two bodies are coming in contact with each other, and time taken between the contact to the maximum deformation is called as period of deformation. And after deformation, they are undergoing separation. Then that is nothing but period of restitution. Okay, what is the period of restitution? It is time elapsed between the maximum deformation to the till the separation is called as period of restitution. So maximum, the velocity at the maximum deformation is ud max, and the velocity at the separation is called final velocity v. Okay, so here you are determined the force required for the maximum deformation is fd, and the force required for the restitution is fr. You have determined the impulse during the deformation and impulse during the separation, restitution, and the ratio of those two is called as coefficient of restitution. Okay. Yes, in the morning you have determined, see, that derivation is not required. Just for your understanding purpose, I have taken that one. So that is fr into dt divided by fd into dt is equal to what is that one? V2 minus V1 divided by U1 minus U2. Is it correct? What is this V2 minus V1? Relative
Separation
velocity of separation to the relative velocity of approach. Correct. So this ratio is called as coefficient of restitution. So after this statement, write this one. Sir Isaac Newton conducted the experiment and observed that the constant of this ratio is coefficient of restitution. And is denoted by E. Therefore, E is equal to Fr into dt divided by Fd into dt that is equal to V2 minus V1 divided by U1 minus U2. U1 minus U2. Definition. Write the definition for the coefficient of restitution. Okay, I will write in the next slide. This definition is important for the exam point of view. The coefficient of restitution. The coefficient of restitution of two colliding bodies of two colliding bodies may be taken as the ratio of impulse during restitution period to the impulse during the deformation period. During the deformation period. This is also equal to, next line. This is also equal to the ratio of relative velocity of separation to the relative velocity of colliding bodies the relative velocity being the relative velocities being measured in the line of impact. Okay, so this is the definition for the coefficient of restitution. So here you have seen the that is the derivation. Okay, so this is what is this one? FR into dt. FR into dt is what? That is impulse during the restitution period. Okay, FR into dt is impulse during restitution period. Correct? And this is FD into dt, deformation period. FD into dt is impulse during the deformation period. So coefficient of restitution is the ratio of impulse during the restitution period to the impulse during the deformation period. Okay, and this can also be written as it is the relative velocity of the separation to the relative velocity at the approach, or relative velocity of the colliding bodies. the relative velocity is being measured in the line of impact. Is it clear, everyone?
Yes, sir.
Yes. Okay. So now if you know this one clear, then you should know what will be the value of this coefficient of restitution. See, this is a coefficient, correct? Na? So there should be some value. Then what will be the value? So this value depends upon the elasticity of the material. If the body is elastic, then the material range is different. If the body is inelastic, then the range is different. Okay. Take a note. So this note can be asked in your multiple choice questions. For perfectly elastic bodies, for perfectly elastic bodies, magnitude of relative velocity, magnitude of relative velocity, after impact, after impact will be same as that of before impact, and hence coefficient of restitution will be coefficient of restitution will be 1. Then second point, for perfectly inelastic bodies cling together and hence the velocity of separation will be 0, that is coefficient of restitution will be 0, that is coefficient of restitution will be 0. Therefore, E value always lies in between 0 to 1. Okay. See, when you take the perfectly elastic body, okay, when you put it on the heat wall, it will come back with the same. It means the approach velocity is equal to separation velocity. When the approach velocity is equal to separation velocity, then the ratio is equal to 1. Okay. So according to this formula, this formula, if both are velocities, approach velocity is equal to approach is equal to separation velocity, then this ratio is equal to 1. Okay. If at all the material is perfectly inelastic material. Okay, when you throw a material to the wall, then that will not come back. Or if you take the floor, you put the iron ball on the floor, whether it will bounce back? No, it means the approach velocity is different from the separation velocity. So in that case, the coefficient of restitution will be equal to 0. Okay. See this one. So what is this one? Relative velocity of separation. So separation means after impact. After impact, velocity will be equal to 0. Before impact, you are giving some velocities, correct? So 0 divided by anything is equal to 0. So that's why this ratio coefficient of restitution is having the value lies between 0 to 1. So in the exam, he may ask the coefficient of restitution value is equal to 1 for the perfectly elastic body, perfectly inelastic body, partial elastic and partial inelastic, none. What is the option? Yeah, that is for perfectly elastic, the E value is 1. For perfectly inelastic, the E value is 0. For the partial value, the E value lies between 0 to 1. Is it clear, everyone? Yes.
Yes, sir.
Yes. Okay. Then the value of E, it is not only depending on the value of initial velocity, but also it is depending on the sum of the parameters. Okay, you have written this point. You write on this one more point. The value of coefficient of restitution. The value of coefficient of restitution, that is E. Okay, I am writing short form CR. That is coefficient of restitution. Depends not only on the material, not only on the material property, but it also depends on the shape and size, shape and size of the body, hence the CR, coefficient of restitution, is property of two colliding bodies, not merely of two material of the colliding bodies, So direct central impact. So you may get the problems from this one and how to solve the problems by the direct impact solution. Let U1, U2 be the initial velocities and V1, V2 be the velocities after collision of bodies 1 and 2 respectively. Let W1 and W2 be the weight of colliding bodies and E be the coefficient of restitution coefficient of restitution, coefficient of restitution, full stop. U1, comma, U2, comma, W1, W2, and E are known quantities. Known quantities. Velocities after collision. After collision. What is the velocity after collision? V1 and V2 are unknown. To find these velocities, two unknowns, we need two equations. How many equations we need? We need two equations. One equation is obtained by the principle of conservation of momentum. Principle of conservation of momentum. As W1 divided by G into U1 plus W2 into U2 divided by G is equal to W1 divided by G into V1 plus W2 into V2 divided by G. So this can also be written it as, that is W1 U1 plus W2 U2 is equal to W1 V1 plus W2 V2. So this is from the principle of the conservation of momentum equation. So this is equation number 1. This is equation number 1. Have you written? Another equation based on the definition of coefficient of restitution, based on the definition of coefficient of restitution may be written as yes, what is the E? What is the value of E? E is equal to V2 minus V1 divided by
upon U1.
So can I write this one? U1 into E into U1 minus U2 is equal to V2 minus V1. Can I write? Is it okay? Yes, this is the equation number 2. See, whenever two bodies are coming and impacting, okay, so we know masses, that is weight, W1, W2. Okay, W1, W2, initial velocity U1, U2. And we know the coefficient of restitution also. So how to find out the final velocity? So in the problem, he is asking what is the separation velocity. So these two are the formulas you have to use. One is by the principle of conservation. Okay, this one, and coefficient of restitution. See, what are the unknown here? W1 is known, U1 is known, W2, U2 is known, V1 and U2 is unknown. So here coefficient of restitution is known, u1, u2 is known, v1, v2, v1 and v2 is unknown. So two equations, two unknowns, you can easily find out. Okay. Okay. From equation 1 and 2, from equation 1 and 2, the unknown, no, the unknown velocity, the unknown velocity, v1 and v2 may be found. May be found. Okay. So this is all about the impact theory. Have you written?
Yes, sir.
Yes. So now you can take the problems over this. You have to remember these two equations. One is the coefficient of restitution and one more is the principle of conservation of momentum. Okay? May be written as. May be written as. Okay? Yes. Okay. Take down the problem. Okay. Take down the problem. Direct central impact. Direct central impact direct central impact occurs between occurs between occurs between a 300 Newton body moving to the right, moving to the right with a velocity velocity 6 meter per second 6 meter per second and 150 Newton body 150 Newton body moving to the left, moving to the left with a velocity of 10 meter per second. Find the velocity of velocities of each body find the velocities of each body after impact if the CR, what is CR? Coefficient of restitution is 0.8. 0.8. Okay. So first write down the data what is given. See, direct central impact is given. Occurs between the body. So first body weight is given. So that is W1. Is it mass or weight? Weight. W1 is equal to 300 Newton. Then it is moving to the right with a velocity of 6 meter per second. So initial velocity, correct? U1 is equal to 6 meter per second. So it is moving right, correct? Then with a velocity of 6 meters per second. Then second body is 150 Newton body. So W2 is equal to 150 Newton body with moving moving to the left with a velocity. So U2 is equal to, that is minus 10 meter per second. It is to the left. Are you getting why I have taken minus? Because it is towards the left. Then find the velocities of each body after the impact. After impact, what is the velocity? V1 and V2. Means V1 is how much and V2 is equal to how much. And he has given coefficient of restitution is equal to 0.8. So how to solve this problem? By using two equations. One is principle of conservation of momentum and one more is restitution definition. Okay. Okay. First one. So from principle of conservation of momentum, principle of conservation of momentum. Yes, what is the formula? W1 W1 U1 plus W2 U2 is equal to W1 V1 plus W2 V2. Correct? Okay. Substitute the value of W1 is how much? 300 into what is the U1? 6. Then W2 plus W2 is equal to 150. So U2 is minus 10. Yes. So W1 that is equal to 300 into V1 plus 150 into V2. Okay. Solve this one. So simplify. So I will divide this entire by 150 or 150 or 1500. Okay, wait. I will write this right hand side as it is first. So 300 into V1 plus 150 into V2. Okay, this is equal to. So calculate this one. 600, 300 into 6 minus 150 into 10.
300.
300, okay. Okay, 300. So you can divide this entire by 300. Okay, you can divide by 150. So 2 V1 plus V2 is equal to 2. Is it correct? So this is equation number 1. Correct, Aina? Okay. From definition of coefficient of restitution E into tell me U1 minus U2 is equal to V2 minus V1. Correct? Okay. So E value is given 0.8. U1 is given how much it is? 6. Minus of minus. Okay, minus of minus. Correct? So it is minus of minus 10. That is equal to V2 minus V1. So open the bracket. So minus of minus it is plus 10 in plus 6. 16 into 8.
12.8.
Okay. So 12.8. So this is 12.8 is equal to V2 minus V1. So can I write this one? V1 minus V2 is equal to V1 minus V2 is equal to minus 12.8. That is equation number 2. Okay. So add 1 and 2. Add 1 and 2. So V2 get cancelled. So addition because these are minus I. Okay, solve it. However, okay, I want the value of V1 and V2. Okay, solve it. Okay, आपको जैसे in case if you want to solve, you solve by calculator. Okay, वैसे भी कर सकते हैं. Add 1 and 2. So that is V1 plus 2V1. That is 3 times of V1 is equal to minus 12.8 plus 2. That is equal to minus 10.8. Minus 10. So V1 is equal to how much? V1. Is it correct? 3.6. Okay. Then
minus 3 point.
substitute this V1 in equation number in 1. So in one equation, so 2 times of minus 3.6 plus V2 is equal to 2. So substitute V2 is equal to 9.2. Yes, correct. 9.2 meter per second. Take calculator से. Yes. Don't confuse between V1 and V2. Coefficient of the first one किसका डाल देना, that value you will get V2. So this is the problem. How to solve this problem. Understood, everyone? So what I have done, I have considered the two equations, two unknowns. First unknown is first equation is from the principle of the conservation of momentum, and second equation is from the definition of the coefficient of restitution. Completed.
Yes.
I will give one problem of the similar kind. Can you solve it? Homework. Okay. Take down one problem as homework. Problem number 2. Homework. Huh? A 18 Newton body. 18 Newton body. Moving to the right. Moving to the right. At a speed of 3 meter per second. 3 meter per second. Strikes a 10 Newton body. 10 Newton body that is moving. That is moving to the left. To the left at a speed of 10 meter per second. The final velocity of 10 Newton body. 10 Newton body is 4 meter per second to the right. To the right. Calculate coefficient of restitution and the final velocity of the 80 Newton body. 80 Newton body. Okay, so here you have to find out the V2 and also E value. Okay, so this is homework for you. Take the next problem. A golf ball. नहीं solve करो. A golf. No, I will extend. तो भाई कितने बजे गए थे? 5:30 को है ना, अभी 5-10 मिनट में खत्म करेंगे. लास्ट प्रॉब्लम. ए गल्फ बॉल 10-15 मिनट में लेट से चालू किया. ए गल्फ बॉल इज ड्रॉप्ड. Golf ball is dropped from a height of 10 meter on a fixed steel plate full stop. The coefficient of restitution CR, the CR is 0.894. Find the height. Find the height to which the ball rebounds on the first, second and third bounces. Okay. Question mark. So the problem is there is a one golf ball and you are the golf ball you have dropped from the height of 10 meters. So after on the steel plate, after striking to the steel plate, it comes bounce back. Okay, how much it is bouncing for the first bounce, second bounce, third bounce? You have to determine the height. Okay, so this is the problem. Initial height is how much? Initial height. H0, I will take it as H0 is equal to 10 meters.
10 meter.
He has given coefficient of restitution. He has given CR is equal to E is 0.84. What is the unit? What is the unit? Coefficient of restitution unit. Meter. It is a unitless quantity. Okay. Velocity divided by velocity. It's unitless. Coefficient of friction. What is the unit for the coefficient of friction? Unitless. Okay. You should remember some of the coefficients. Okay. Next. Velocity of golf ball. Before impact. Can you tell me when a ball is dropped in a freely falling body, it touches the ground. Before touching the ground, what is the velocity? Under root of 2gh. Correct, Aina? So velocity of the golf ball before the impact is equal to under root of 2g. Can I take it as h0? I am taking h0 because of initiality. I have taken h0. Okay. Then velocity of steel plate before impact. Can you tell me what is impact before impact velocity of steel? So this is U2. So this is U1. This is U2. See, the steel plate he has given fixed steel plate. It is not moving. Okay. So what will be the answer? 0. Okay. Then velocity of the steel plate after impact. Can you tell me? Velocity of steel plate after impact. Same after impact. It is also same. That is after impact is V2 is equal to 0. Okay. Then let velocity of golf ball after impact is equal to after impact B. I will take it as V1. Okay, for the ball after impact it is V1. So from definition of coefficient of restitution, what is the definition? E into U1 minus U2 is equal to V2 minus V1. Correct? Okay. E is known. Okay. E is I don't know the value of E. He has given. Okay. Then U1. What is the U1? Root 2 GH0. Root 2 GH0. Okay. What is the U2? 0 minus 0. What is V2? V2 is equal to 0, 0. What is V1? I have to determine V1. E value is known, but I am first writing the general equation. Okay. Have you written this much? Okay, write down. Okay, now write it in terms of V1. So V1 is equal to, how to write this one? V1 is equal to minus E into root 2 G H naught, correct? Why? What does this mean? Minus sign implies what? Because V1, so actually I have taken H, H is downward, body is moving in the downward direction, positive direction. But this V1 means after striking, it is coming in the upward direction. So that's why it is minus. Okay. So V1 is equal to minus E root 2 GH naught. So this can also be written as E into root 2 GH naught. So here in upward direction, in upward direction. Yes. Wait. Velocity. What he is asking actually, find the height to which the ball rebounds. Height चाहिए हमको. B2 B1 नहीं चाहिए. Okay, height चाहिए हमको. So from kinematic equation, the height H1. See, after bouncing back, the height is similar as that of the initial, or it is less. It is less. Okay, I will take it as H1. Okay, so the height H1 to which the ball will rise is given as or given by, see, from the kinematic equation, the height H1 to which the ball will rise is given by, so V1 square minus what is the initial velocity? It is equal to 0, is equal to 2g H1. So V square minus C square is equal to 2gh. So this, then H1 is equal to V1 square divided by 2g. Then what is the V1? You have calculated this equation. So that is equal to E square into 2g H naught divided by 2g. So this 2g get cancelled. So what is H1? H1 is equal to E square into H naught. So this is the standard equation you have to remember. Okay. So whenever you want to determine the next bounce height, that is equal to E square into initial height. So E square is the coefficient of restitution. So now you can substitute H1 I want to determine. What is the E value? 0.894. 0.894 square into what is the H1? Sorry, H naught, initial height, 10. So can you tell me what is the value of H1? H1 is equal to 7.992 meter. See, first you are dropping the ball by 10 meter height. After striking, it is giving a bounce back by 7.99 meter. Okay, then again, if we next bounce, it strikes. Okay, that should be less than this 7.9. So that is H2 is equal to. Okay, I will write that one. Similarly, after second bounce, the height to which the ball will rise, is given by, yes, can you tell me for the second height? H2 is equal to E naught square, E square into H1. Yes, H1. Okay, so calculate 0.894 square into H1 is equal to 7.992. So H2 is equal to 6.382 or 388 meter. Then, and after third bones, and after third bones, the height h3, the height h3 is equal to e square into h2, correct? So e is equal to 0.894 square into h2. What is the value of h2? 6.388. 6.388. So h3 is equal to 5.105.
5.2105.
So these are the heights after the first, second, and third bones. Okay. So in the exam, he may give the initial height is given and the coefficient of restitution will be given. Then after bouncing, after striking, how much is the next height? Directly you can use e square into initial height. If he is if he has given first height, second height, third height, if he is asking for the next third height, then you have to find second. Okay. Is it clear? Okay. So remaining things will continue in the next class. In the next class, we'll complete this chapter. Just a minute.
Sir, 6th chapter क्या assignment?
6th chapter का assignment. हाँ, I will upload. 6th and 7th I will upload. Okay. Just a minute. Hello. Hello. Just wait. I will take the attendance. Six. Roll number 6 absent. 10, 11, 10 and 11, 12, 13, 14, Prajwal, 15, 16, 16, 20, 21, 22, 25, 27, 29, 31, 38, 38, 44, 44, 52, 53, 53, 57, 59, 61, 62, 64. See absent number 6, 12, 13, 16, 21, 22, 25, 27, 29, 31, 44, 53.
Then
Plus 29,
25.
27. Your voice is not properly audible.
25, sir.
25, 27. 25 is present, 27 is absent. 29, 31, 44, 53, 57, 59, 62, 64. Okay. So we stop now. We'll continue next. Thank you all.